Transistor characteristics. To study the transistor characteristics, here I am choosing common emitter configuration. The relation between currents in a transistor is IE is equal to IC plus IB. IE indicates emitter current, IC indicates collector current, IB indicates base current. To measure the currents IE, IB, IC, let us insert ammeters to measure these currents. Ammeters are included in the emitter circuit, base circuit and collector circuit. So the ammeter in the collector circuit reads IC, the ammeter in the base circuit it measures IB, ammeter in the emitter circuit measures IE. Collector current IC depends on VCE and IB. VCE is output voltage, voltage between collector and emitter. This is the case in the case of common emitter configuration. In common emitter configuration, the collector current depends on base current and output voltage, VCE, collector voltage. Base current IP depends on base to emitter voltage VBE and output voltage VCE, collector to emitter voltage VCE. Base current depends on VBE and VCE, and IC, output current or collector current, depends on VCE and IB. To study the relationships between currents and voltages, we draw graphs between them. The relationships are the characteristics, and we use the graphs to study these characteristics. We call them as characteristic curves. These characteristics enable us to choose the choice of parameters and hence the configuration best suited for an electronic circuit. In choosing the components for electronic circuit, these characteristics, they are highly helpful. In a transistor, the current is transferred from low resistance to high resistance. Current is transferred from low resistance to high resistance in a transistor. Input junction is always forward biased, so its resistance is low, and the signal will be given in this circuit, in the base circuit. So initially the signal appears across low resistance. The output is reverse biased, so it has very high resistance. So the current will be transferred from base circuit to collector. So input to output, that is low resistance to high resistance. In this case, in common emitter configuration, it is transferred from emitter junction to collector junction. Let us study the circuit used for the study of characteristics in common emitter configuration. Here I am using a PNP transistor, and I have shown the ammeters and voltmeters meant for reading IC, collector current, VCE, voltage between collector and emitter, IB, this is ammeter which measures base current, VBE, it is a voltmeter which measures the potential difference between base and emitter. IB, base current, VBE, voltage between base and emitter, IC, collector current, VCE, voltage between collector and emitter. Now, instead of using a constant source, we are using a variable source. That means we can change the voltage applied. The circuit in the rectangle indicated with dotted lines. On the left side, there is a rectangle of dotted lines. Inside that, there is a circuit that represents a variable voltage source which is used in input, that is between base and emitter. Similarly, there is another circuit under the rectangle with dotted lines. on the right side. This circuit indicates a variable voltage source which is used in output circuit. So both input voltage and output voltage can be varied. To vary this voltage, we use variable voltage source. So these two variable sources are shown under rectangles of dotted lines. I have already explained the symbols that we use here. VBE stands for voltage between base and emitter. VCE stands for voltage between collector and emitter. IC represents collector current. IB represents base current. We also know that VCE can be varied with the sliding contact of the arrow mark on the right side resistance. The arrow mark on the left side resistance indicates the variation of voltage, variable contact. IC changes with the change in VCE and IB. IB varies with changes in VBE. Input characteristics of common emitter configuration. Input characteristics of common emitter configuration of a transistor. Input characteristics means the relation between base current and voltage between base and emitter. The relation between base current and voltage between base and emitter, VBE. So relation between IB and VBE is known as input characteristics. We know that IB depends not only on VBE but also on VCE, output voltage, collector voltage. Because IB changes with collector voltage, we study the relation between IB and VBE at a constant output voltage, collector voltage. So we select VCE as constant voltage of 10 volts, we keep output voltage as 10 volts, and by varying VBE we measure IB and we draw a graph between VBE and IB. Then the curve will be obtained as shown in the figure. This curve indicates that IB increases with increase in VBE. Even if VBE is having some value, IB is 0. So it starts at a particular value of VBE. As VBE increased, IB also increases at a constant VCE. Now I have shown two graphs, one for VCE is equal to 5 volts, another one for VCE is equal to 10 volts. That means we will get different curves for different values of collector to emitter voltage. So these are the input characteristic curves of a common emitter configuration transistor. Output characteristics of a common emitter configuration transistor. Output characteristics of the transistor. Output characteristics are the relation between collector current and collector voltage. The relation between collector current and collector voltage is known as output characteristics. But the collector current depends not only on collector to emitter voltage but also on base current. It depends on two factors. One, VCE and IB. So to study the relation between VCE and IC, we keep IB as constant. We select different values of IB. First, let us take 10 microamperes of current in base. For this current, we measure the collector current for different voltages. By keeping base current as 10 microamperes, collector voltage is changed and collector current is measured, and the values are plotted on this graph taking VC and x-axis and IC and y-axis. Then we will get a curve of the form shown 10 microamperes. Then we increase the current to 20 microamperes. The base current will be changed to 20 microamperes. Then the relation between VC and IC is studied. Then we will get the second curve. Like this, we will get different curves for different values of IB. These curves are drawn in the figure. Now, at a particular base voltage, if we observe the relation between collector current and collector voltage, as the collector voltage increases, the collector current increases, but after reaching certain value, it almost remains constant. So it reaches a saturated state. The collector current becomes maximum, almost reaches a saturated state for a particular voltage of the collector to emitter. And above these voltage values, this current remains constant. So this is the output characteristic curves. Current gain. Current gain is defined in common base configuration and common emitter configuration. It is the change in the output current to the change in input current. That is the ratio of the change in output current to the change in input current. In the case of common base configuration, input current is emitter current and output current is collector current. So the current gain alpha in common base configuration is defined as delta IC by delta IE. Delta IC is change in collector current, delta IE is change in emitter current. Alpha is defined as delta IC by delta IE. Similarly, current gain in common emitter configuration is indicated with beta. Current gain in common emitter configuration is indicated with beta. Here, in common emitter configuration, output current is collector current, input current is base current. So beta is defined as the change in collector current, the ratio of change in collector current to the change in base current. So beta is equal to delta IC by delta IB. Change in collector current by change in base current. Delta IC by delta IB. This is beta. In a transistor, the relation between currents is given by IE is equal to IC plus IB. In a transistor, the relation between currents is IE is equal to emitter current is equal to collector current plus base current, IC plus IB. So change in emitter current delta IE is equal to change in collector current delta IC plus change in base current delta IB. Delta IE is equal to delta IC plus delta IB. Dividing throughout by delta IC, we get delta IE divided by delta IC is equal to delta IE divided by delta IC is equal to 1 plus delta IB by delta IC. Delta IB by delta IC. But delta IC by delta IE is alpha. So delta IE by delta IC is 1 by alpha. Similarly, delta IB by delta IC is 1 by beta. Therefore, 1 by alpha is equal to 1 plus 1 by beta. 1 by alpha is equal to 1 plus 1 by beta. Therefore, 1 by beta is equal to 1 minus 1 by alpha. 1 by beta is equal to 1 minus 1 by alpha, or beta is equal to alpha. Common emitter configuration of NPN transistor is used as an amplifier. First, let us study the circuit diagram. BCE indicates base, collector and emitter, and the arrow from B to E represents this is an NPN transistor, and a battery BB in connection with a series resistance is connected between base and emitter. IB indicates the current through the base, and VBE is the voltmeter which reads the potential difference between base and emitter. And another bias BC is taken. This is connected through a series resistance between collector and emitter. So collector is reverse biased. And IC indicates the ammeter which reads the current. And VCE is the potential difference between collector and emitter. Now this is how the circuit is. First, the transistor is biased. Then after biasing this transistor, we take the input voltage, that is an AC signal V in. It is connected in series with the BB in the base circuit. The output voltage will appear across the load resistance. VO represents the output voltage. This is how the circuit diagram is represented. One of the uses of transistor is that it acts as an amplifier. An amplifier is a device which strengthens a small signal. A weak signal will be strengthened into a strong signal by an amplifier. Here, I have taken an NPN transistor and it is in common emitter mode configuration. It is in CE configuration and it is used as an amplifier. So NPN transistor in CE configuration, which is acting as an amplifier. Now let us study the amplification. Now the transistor is biased. BB indicates base bias, that is emitter junction bias, and BC indicates output junction bias. The battery BB indicates input bias and BC indicates output bias. Then a small signal, AC signal, by indicated here by Vn, Vin indicates input voltage, a small signal, AC signal. It is given in series with the bias, input bias. Now this signal will be amplified and given out as VO, that is output signal. That is also AC signal. But VO will be very strong compared to Vin. Output signal VO will be very strong. It will be the signal is obtained by amplifying Vin. Input voltage is amplified and given out as VO. Now this is done as follows. Due to the input voltage Vin, the voltage VBE, base to emitter voltage, will change. A change takes place in VBE and thereby the current IB changes. Due to input voltage Vin, the input voltage VBE bias will change and input current will change. Because of the change in input current IB, the IC output current will also change. Because of the change in output current, the voltage VO will be obtained across the load resistance. So this is how the input signal is initially given to a low voltage, a low resistance, because emitter junction is forward biased, its resistance is very low. So this gives a small current. Thus that current will be amplified because it is transferred to a large resistance. Output resistance is very large, hence it will be transferred to a high resistance, so a high current will be obtained and thereby a large voltage will be obtained. The current will be transferred to high resistance, so hence the voltage will become large. So VV will be larger than Vin. Like this, a weak signal will be strengthened by the transistor. So such an action of a transistor is called amplification. So transistor. Now we study the gain in the case of amplification. When the transistor acts as an amplifier, we calculate current gain, voltage gain and power gain. We define them as follows. Current gain is indicated with beta and it is defined as delta IC by delta IB, that is change in collector current to change in base current. This ratio is called current gain and is indicated with beta. And voltage gain is defined as the change in collector to emitter voltage, delta VCE divided by delta VBE. The ratio of delta VCE to delta VBE is termed as voltage gain, change in output voltage to change in input voltage. Power gain AP, voltage gain is indicated with A, capital A. Power gain is indicated with AP. It is equal to current gain into voltage gain. So by calculating current gain and voltage gain, we can calculate the power gain of the transistor. Generally, these transistors, NPN common emitter configuration transistors, they will be designed such that IC will be 0.95 IE to 0.99 IE. IC, the collector current will be about 0.95 times the emitter current to 0.99 times the emitter current. The current gain of these transistors will be around 50. Sometimes The transistors will be designed with a current gain beta of value 50.